So this is the agenda, and I'm not going to bore you with the group history. Everybody knows that. I just want to mention that Yan and I go way back, like he helped me. You really allowed me to borrow some of the slides for the first Serverless Toronto meetup, so I owe you for that. And then you revisited us for like almost 4 years ago. You taught about step functions, and what changed since that time. Like we are now taking looser definition of serverless more like as a mindset rather than just the tech stack, which and like it's Yan Cui that brought up the definition. So that allows us to bring different presentations to the group. And you can check our YouTube channel, and the next meetup will be with our friend here, Pankaj. He's going to be explaining how he's using generative AI and AI to grow his startup Lagna 360. And then I'm also talking with the presenters from the AI Camp meetup. It was related to Azure OpenAI, because lots of folks like OpenAI, but companies not confident giving their data and customer data to them. So they ended up hosting to Azure Cloud. And we only had 2 meetups about Azure. So it's time to go deeper into that. And then we need you like submit your ideas, anything that's meaningful, impactful, helping the world. We are open to help you. And then please scan this barcode. You know that at the end of every meetup, Manning gives a free product, anything they have. But just this month, they created this code, Toronto 24, for us, and they ask you to go to this weird-looking URL, Manning and DZV, or scan this barcode, and then you will be getting 45% off. So you don't need to wait for a couple times a year for 50% promos, or to win in Raffle here. You can always use this code. And so thank you, man, much appreciated. So, and then in order to win in the Raffle, please do the survey, this bit.ly SLSTO, or if you don't want to go through the form, just paste your name in the chat and I'll enter you. And now, our feature presenter, Yan, I'll be honored. Thank you for coming back. Please take it away. Stop sharing.
No worries. Daniel, can you allow me to share my screen?
I
says
will.
Host disable participant screen sharing.
I will make a co-host. So now you're co-host. I think you can share.
Okay. All right. Let me check. This will stop others. Okay. All right. Cool. I'll do that. Share my screen. Okay. All right. So I think you can see my screen.
Yeah, looks good.
Okay. Cool. All right. So yeah, thanks everyone for joining us this lunchtime. So I've just put together a couple of tips for saving money on your serverless architecture. I guess normally I want to start with just some instructions about just what do I mean by serverless. But I think for this group, we might be okay. But yeah, normally I define serverless as basically any technology where I don't have to manage servers or EC2 instances. There's no planned downtime, and I can just use it like a service. And ideally, I like to have a usage-based pricing that scales to 0, so there's no minimum charge when there's nobody using my application. But unfortunately, not everything fits into this definition nicely, which is why I think a lot of people actually consider serverless to be more of a spectrum, whereby on the one end, you've got things like EC2, which is definitely not serverless. And then on the other end, you've got things like DynamoDB, S3, SNS, and Lambda, which are very much a serverless by the definition we have. So I think the great thing about building with serverless technologies is that it's very scalable. If you look at how quickly Lambda is able to scale these days, especially after the change they announced at the reInvent last year, it's really great. And it's also out of the box. You're going to get really good baseline resiliency because things like Lambda, DynamoDB, and API Gateway, they will deploy your application to 3 availability zones by default. And also with Lambda, you don't have to manage the operating system. You don't have to patch them. You don't have to manage the underlying EC2 instances, which means you can pretty much remove entire classes of vulnerabilities from things that you have to worry about. And also, I think for especially relevant for today's talk is that the pay-per-use pricing model means that serverless can be very cost efficient, especially when you've used it correctly in the right context. But we all know that AWS is hard. There are lots of similar services, different ways to do the same thing, and it's not always clear which one is the best. And it's really easy to make mistakes. And those mistakes can sometimes be very expensive. And even simple mistakes can really tear you a new one and cost you quite an arm and a leg. And so in the 15 years I've been working with AWS, I've made my fair share of mistakes, and sometimes cause a bit of a problem. But hopefully I've learned from those, and I'm here to share with you some of the lessons I've learned along the way. So nowadays, I spend some of my time working with the team at Lumigo to help them share their story with the rest of the community. The other half of my time, I work as an independent consultant, and I help companies adopt serverless with training and advisory, and sometimes help them build their product as well. So in terms of the actual lessons I want you to take away, I think the number one is definitely that everybody needs to have billing alarms. Doesn't matter what you do, whether or not you're doing fully serverless or fully running containers, you need to have billing alarms. And it's something that everybody should be doing as the first thing you do when you open an AWS account. They're not perfect, usually quite a few hours behind real time. But it's still much better to find out whether there's a problem a few hours late than a few weeks late when your bill actually arrives. And I saw this from Luke Van Donkersgoed, who is a principal engineer at the PostNL. It's a really good example of how a simple mistake. In this case, I think they were, instead of caching the response from a secrets manager, they were making a call on every single Lambda invocation instead. And so in just a few hours, they were able to accumulate about $2,000 in the AWS spending, and so they got the alarm, and so they were able to, by that at that point, figure out what had happened, fix the problem before they cause even more of an issue in terms of the cost they're going to incur at the end of the month. So luckily they were able to do this because they had a billing alarm in place, and they were able to mitigate some of the damage that has been caused by what they had done. Another one that comes up all the time is when it comes to applications running on AWS, maybe just in general as well, is the cost of monitoring sometimes can be orders of magnitude much more than your actual application itself. And I think this is particularly true when it comes to serverless, when you consider that things like API Gateway and Lambda can be really cheap. And oftentimes, because of the generous free tier, you're probably not going to be spending any money on Lambda. But pretty much every client I've worked with, when I look at the AWS bill, CloudWatch logs and the metrics, and basically CloudWatch cost is usually one of the top 3 items in their bill. And the worst thing is that as your spending goes up and you collect more and more data in CloudWatch, you actually get less value from them because you just get a lot of noise. And CloudWatch is not particularly good at surfacing the things that are actually valuable, the actually actionable information from the amount of data that you're collecting. So the number one thing that I want to do is, when it comes to keeping CloudWatch logs cost under control is to make sure that you're doing structured logging so that you're using and you're paying attention to what log level that you are using for every single message that you're writing. So that way, in say in the lower environments up before production, you may be logging a lot more information about debug level so that you can help you track down the bugs that you have in your application. But then once you get to production where you're going to have a lot more volume, it's much better to be logging at a higher level. So at least info, maybe warning or error, so that you're not going to collect as much logs that are of low value once you go into production. But you still have sufficient amount of information so that hopefully we can tell you when something goes wrong. You've got the error logs and whatnot. And instead of logging debug logs all the time, a common practice to have the cake and eat it as well is to sample your debug logs in production. So say for about 5 or 10% of your Lambda invocations, you will have the debug logs. But then the rest of the time, you're gonna be logging as a warning or error. So that way, hopefully you will still have enough logs to cover every single code path you have in your application, so that when something does go wrong, you have your error logs, but then you also have the debug logs to go with them as well. But for the rest of the time, you're not gonna be spending a lot of money collecting debug logs that doesn't add a lot of value. Another thing to do is to make sure that don't forget to set the log retention to some reasonable amount of time. 30 days is my go-to, and because by default, CloudWatch never expires your logs, and it does charge, I mean, maybe small amount, it charges you per gigabyte per month, but if you just keep adding more and more logs, and this cost is just going to keep growing every month, and especially if you're not actually making use of that data, is kind of just a waste more than anything else. And many of you are probably also using third-party services for your logs already. And so you're probably using Lambda to forward all of your logs to some other vendor where you can more easily do centralized loggings and collect all of your logs from different applications, different accounts, and see them and query them all in one place. And so in that case, if you're going to be doing the log, you're going to collect the logs in CloudWatch first, and then you're going to pay for ingestion. In this case, I think 50 cents per gigabyte of data that you collect in CloudWatch, and then you're going to be paying for the processing in the Lambda functions or whatever you're using to forward the logs to the third-party vendor, where you are also going to be paying for storage and processing for those log messages as well. So again, this is just a bit of a waste because you're double paying for the logs that you are processing and the storing for the amount of time that you're actually going to need, that they're actually going to be useful. So way that I've seen more and more people do it nowadays is to use the Lambda extensions to ship your logs so that you can use the Lambda's telemetry API, which allows Lambda extensions, which are kind of like sidecars to your main Lambda runtime, to access the logs from your function, and then it's able to send them to the third-party vendor directly, and be able to and therefore bypassing CloudWatch altogether. And so in this way, you can actually disable your Lambda functions permissions to write to CloudWatch logs. So all of your logs doesn't get processed by CloudWatch logs. And so you're not going to be paying for that that processing cost that CloudWatch logs going to have. And instead, you're going to use the Lambda extensions to ship all of your logs to your third-party service instead. So I do a lot of work with Lumigo, as I mentioned earlier. They've also just launched a new log management system, so that and it's priced a lot cheaper compared to things like Datadog and the CloudWatch. So if you're looking for something to do centralized logging, Lumigo now is going to give you a very cost-effective solution to do that as well. And I'm pretty sure they've got the Lambda extension to ship the logs straight from your Lambda functions as well. And so talking about some real-world examples, I saw this tweet from Jack Ellis, who's the co-founder of Fathom. So they had this pretty big CloudWatch bill for about $1,000 a month. But essentially all they're getting is the system logs from Lambda, because they didn't actually log anything from their functions. And still, because there are so many invocations, they were paying $1,000 just for the, start and the report log lines in the CloudWatch. So this is the kind of thing that that oftentimes I find people see people end up paying CloudWatch logs for, which is obviously not ideal. The good news is that besides using Lambda extensions and shipping the logs to yourself, there's also other additional controls you have with Lambda nowadays. So this was announced at the reInvent last year. So now you've got some additional controls for the configuration for your Lambda function, whereby you can set a log format for your function, and the default is to just text, but you can actually set your log format to JSON. So when you do that, Lambda is going to turn all of your log messages, so anything that you write to send it out and send the error in, and wrap into a JSON structure. So this, on the face of it, you may say, okay, that's actually going to create more log messages, bigger log messages for CloudWatch. But once you've done this, is that you can also set the system log level. So in this case, this system log level allows you to control which of those system messages gets recorded and therefore sent to CloudWatch. So if you set the debug level, then you're going to get everything, of course. But if you set it to info, then you're not going to get some of the messages like when the Lambda execution environment is initialized, it sends a report message for the init runtime done message. And you're not going to get the start messages for every invocation as well. And also importantly, if you set it to warn, then essentially you're not going to get any of those system messages that Fathom was paying $1,000 a month for. And so you're only going to get those error messages when they do happen. So in this case, you can pretty much stop all of those nonsense messages that CloudWatch, the Lambda generates for your invocations. So in this case, you're just going to get those error messages when something happens, which makes life a lot easier when it comes to keeping your CloudWatch logs cost under control. even without doing something like using Lambda extensions to ship them somewhere else. Another thing that comes up oftentimes when I talk about keeping the cost of your serverless architecture down is the cost of Lambda functions. I actually find this one oftentimes goes one of the other ways because with Lambda, the more memory you allocate, it's also going to give your function more CPU as well as more network bandwidth. But the cost per millisecond of execution time is also directly proportional to the amount of memory you allocate as well, which kind of give you both the power control and cost control with just one setting. The trouble here is that, okay, that's all great, but it's really easy to get something wrong by an order of magnitude. It's really easy to, okay, let's just put the 1 gig of memory down and without even thinking about it. And maybe if it's applied to most of your functions, it'll be fine. But maybe you have 1 or 2 functions that are executed very often or runs for a very long time, where those large amount of memory may not be very good, and you can get hit pretty hard in terms of the cost of those functions. So I actually had a client a while back I was helping with. So they had lots of Lambda functions, a couple hundred of them in their AWS account, most of which was just running it for maybe costing a few cents a month. But they had one function that was costing them about $10,000 in 1 month. And the reason for that is because it's a function that does video encoding. And so every time that function runs, and because the business that they're in, it runs a lot, because every time someone uploads a video, they need to process it with this Lambda function and encode it and all of that. And so every time it runs for quite a lot of time as well. The problem is that one of the developers thought, oh, we're not getting things done fast enough. Let's give the function more power by allocating more memory. And they read that, okay, once you get to 1.8 gig of memory, you're going to unlock a second virtual CPU core for your function. And so by the time you hit the 10 gig maximum amount of memory for your Lambda function, you actually have access to 6 CPU cores, which should help you process the videos a lot faster. Unfortunately, they were using Node.js as a runtime, and the Node being a single event loop actually doesn't make it easy for you to use all the CPU cores that you have. Node is great for doing concurrent computation, but not great for doing parallel computation, so that you can't actually easily use all the different CPU cores that you had. So the problem wasn't so much that they were spending $10,000 a month on a single Lambda function. The problem is more that well, basically 70% or 80% of that was being wasted because they had all these CPU cores they weren't able to make use of because of the way the application is written, didn't take advantage of that. And so again, it's something that's really easy to is just one configuration, and it's really easy to make that mistake and to over allocate memory too much memory to a function that gets invoked a lot or runs for a very long time. Having said that, I do think that you shouldn't be paying too much attention to the memory setting, and if you or trying to be too aggressively in terms of how you optimize that, because as Donald Knuth said, 97% of the time we should forget about small efficiencies. The premature optimization is the root of all evil. Yet we should not pass up our opportunities in that critical 3%. So this is where it's all about identifying functions that has got too much memory, and it also potentially is costing you a lot of money, and identifying that critical 3%. So Lumigo's dashboard has got this very nice thing where they give you estimated cost for individual functions, how much memory is being used, and also how much memory is allocated. So you can see the invocation time and the frequency. So this allows you to quickly identify functions that has got too much memory, and it runs very often and runs for a very long time. And so this is where you can identify that maybe 1 or 2 outliers in your entire estate of Lambda functions that is actually maybe responsible for a large proportion of your costs associated with Lambda. And then so once you've identified those maybe 1 or 2 functions in your, that's causing a problem, and where you're going to get some return on investment in optimizing then that's where you're going to use Alex Casabone's Lambda Power Tuning State Machine, which runs your function for across multiple configurations for different memory settings. And so it helps you see, okay, as I add more memory, performance goes down, performance goes up, so execution time comes down, and therefore maybe the overall cost actually goes down because Lambda, maybe you're spending more money per millisecond, but you are executing for less time, and therefore your total cost for that function actually comes down as you add more memory. So this helps you find the right memory size for your Lambda function. Another thing to think about is whether to run on the x86 or the ARM architecture. ARM is a lot cheaper. I think it's about 25% cheaper or something like that compared to x86. And this is where you really need to test it against your own code and don't just use some off-the-shelf benchmarks from AWS, because when the AWS announced the ARM architecture support for Lambda, they found some of the workload that they tested on was actually faster and cheaper. But when I tested it myself, and I've had a few people talk about this on social media as well, that for their Lambda functions, ARM was significantly slower. So even though on the per millisecond, or rather per gigabyte second cost, ARM is going to be a lot cheaper. But if you end up spending more time, 25% more time to do the same workload, then it's still going to end up being more expensive. So I think ARM is great if your functions have got a lot of I/O wait time. So you're making a call to third-party APIs, and they're taking a long time to come back, and so you spend most of your execution time just waiting for a response. Then ARM is great for that, because you're not doing any CPU intensive work and just doing a lot of I/O waiting. Another thing that I see often, especially some of I guess beginners make mistakes when it comes to Lambda, is they have got this synchronous Lambda to Lambda invocations. So when it comes to calling Lambda functions, everything goes through the invoke API, and you can either do it synchronously or asynchronously by setting the invocation type to either request response for synchronous invocation or event for asynchronous invocation. Now, when you set it to request response and you do invoking your function synchronously, and then I think this is almost always a bad sign. It's always pretty much always a smell that you're doing something wrong. For one thing, when you got one function calling another function, the entire time that second function is running, and because you're invoking it synchronously, so you're waiting for it to finish and get back the response. So you're paying for the execution time twice, and you're also paying for the code start time for that second function, because the first function have to wait for that time as well. And in terms of actually creating abstractions and decoupling your code. Typically, I see people do this within the same service boundary. And if you're doing the same, you're trying to modularize your code by deploying them to different Lambda functions, then I think there's actually not a lot of value to do that, because you already have a code level modularities, within your service, within the same the boundary of one service. So you can get modularity at the code level. You don't necessarily have to have that at I guess the infrastructure level, where you have different code modules in different Lambda functions. It's much better to just have everything in one place, so that it'd be cheaper, faster, and easier to manage and maintain over time as well. And this is, I think, maybe that the name Lambda is just give people the wrong impression, because Lambda is already a concept in programming, and so people oftentimes get mixed up because, okay, I've got a Lambda function in my code that should be mapped to a Lambda function in AWS. And a really good example of how when you condense multiple functions into one, and you end up saving a lot of money, but also improving performance. Again, it's coming from Jack Alice. So they had this setup whereby they had one function takes in a task, takes in some user request and puts it onto a queue, which then triggers another Lambda function to do some processing. And this, obviously, they're doing this because they're worried that whatever the second function is doing is going to add a lot of time. So they try to minimize the user-facing latency, which is what that first function is doing, is handling a user-facing API request. But what they actually found out once they merge everything into just one function and have that first function just do the thing, as opposed to putting onto a queue and for another function to pick it up, was that, well, it actually ended up being faster. As he posted here, the end-to-end latency for that for that action actually came down significantly. Not exactly sure why. Putting stuff onto SQS actually is so slow compared to what they actually end up doing with the in that first function. But also importantly, because of the scale they were running at, they managed to save a combined, I think in this case, $44,000 per year, because that saves a lot of Lambda invocations for that second function, but also all the messages all the costs associated with putting messages onto the SQS queue. So again, if you can condense and combine the different things into multiple functions that you're invoking synchronously, or maybe even asynchronously into a single function, then there's a good chance that you can also save some money there as well. Another very common pattern that you want to apply in your application just in general, and also helps with cost a lot as well, is caching. Caching is almost like a cheat code when it comes to building a performant and a scalable application. And I wrote about the caching for serverless a while back, and basically talk about different places you can apply caching in your serverless architecture. But most of the time, I just keep caching on the client side, but also having caching at the CloudFront level at the edge. Even though you can also do caching at API gateway level, I've almost never had any use case where it makes sense to do that compared to just put the caching level at CloudFront. And sometimes your Lambda function may also want to share information across multiple functions or multiple instances of the same function as well. So that's where you can use things like Elasticache, and more now. I actually prefer to use Memento as well, because Elasticache still requires you to put your function into VPCs, and you have to pay for uptime for the cache nodes. Whereas with Memento, you can actually, it's more of a serverless cache where you just pay for data transfer cost as opposed to paying for uptime for those nodes. And of course, if you just use DynamoDB, then you can also just keep things simple and use DAGs, provided that you're not doing a lot of queries or table scans, because the caching behavior for queries and scans for DAGs is not great. When you update an individual item, it doesn't update the cache result where the item appears in. Another thing that you can also often do, with Lambda in terms of improving performance in terms of cold start is, and this is where we also see effects of caching on the infrastructure level for Lambda, is that, so this is some analysis done by Adrian Stovenberg from Datadog. He found that as the deployment package size goes up, once it goes over 50 meg, by packaging your function as a container image, the cold start time actually goes up, actually comes down to compared to using a zip file. And the reason for that is the way that Lambda has sort of done the container images is sliced them up into 512 kilobyte chunks. It caches them, and it applies a multi-layer caching strategy. And they found that something like 70% of the chunks are loaded from the cache, the level 1 cache, which is basically cache on the worker instances. So that way, everyone, I guess, because everyone uses the same dependencies, so the same binary chunks from your Docker images are just going to be the same as lots of other people. And so they were able to improve this time it takes to load container images, even fairly large ones, much faster compared to zip files once you get to a certain size. So a while back, I also helped a client launch a new social network. We did it with AppSync and Lambda and DynamoDB, and I built a whole backend in a couple of weeks. And we did a lot of work around caching, and we were able to get something like 99% of cache hit rate most of the time. And because most of the user requests are just hitting the cache, so at the end of the month, our AWS bill was something like $60, and most of that is just because of AppSync. And I think this was this app we launched with maybe 20,000 people sign up in the first month, and it was used fairly heavily, and also it's quite a chatty thing because it's a social network. But yeah, we almost had no DynamoDB cost. Again, because 99% of requests are just hitting the cache, and our Lambda cost was zero because, most of the API calls was handled by AppSync and using direct service integration between AppSync and DynamoDB. And yeah, with the caching in place, basically we use the cache to absorb most of the requests. Another one that I guess not a lot of people think about, but can sometimes creep up on you as well, is when it comes to Route 53 cost. TTL is something that can sting you, because Route 53 charges you based on the number of queries people make against your domain. And if you've got the short TTL, and this happened to me a few times in the past, where we had really short TTL on domains that end up being quite stable. So our cost for Route 53 was actually much higher than it really should be. So lesson here is that if you got domains that you know you're not going to change it very often, then use a longer TTL, so that essentially, again, it's about getting more of the caching that you're going to get from the DNS. When it comes to APIs and CORS, CORS is a constant pain for, I guess, a lot of people. And even though in API Gateway, they made it so that you can enable CORS support really easily. It's just one setting you have to enable. But what they probably don't tell you enough is that you do still pay for those CORS requests. And so oftentimes you may, and there's a good chance that you may be double paying for all of those user requests to your API gateway endpoints because you're hosted on the different domain to your front end application. And you may think, okay, yeah, I can just put the CloudFront in front of it, and it's done. Unfortunately, there's actually been a long-standing bug in the API gateway in terms of how it handles the cache headers when you're using the authorization header. So if you're using the authorization header and you haven't specified that header in the access control allow headers response, then the access control max age header just doesn't actually work with API gateway in the response. And because when you enable the CORS headers, there's only there's a lot of the settings are by default, at least with most of the frameworks. So this actually means that a lot of the time your CDN cache is actually not working the way you expect them to when it comes to the CORS requests. And so there's a good chance many of you are double paying for your API gateway requests because you're paying for both the CORS request as well as the actual request afterwards. So one thing you could do, and is instead of using the generated options endpoint that the API gateway generates for you, is just create an API endpoint yourself in API gateway for every single endpoint, and just return the right headers for the authorization header in the access control allowed headers header. Or you can put your API, instead of on the subdomain, you put it on the main domain with a subpath, with a path, so that that way there's no CORS request in the first place, instead of having to worry about getting the caching right for the options request coming from the browser. Another big one is making sure that you're using the right services, because like I mentioned earlier, AWS has got many similar services that does similar things, but they have got different pricing models. And in the cloud, every architectural decision you make is essentially a buying decision, where you're gonna pay for a service, and sometimes using the wrong service can be very costly. So if you just look at the different messaging services that AWS has, off the top of my head, you've got SNS, SQS, EventBridge, Kinesis, IoT Core, all kind of can do similar things, and they can be used interchangeably. And depending on your throughput, at the 1 request per second, SNS and SQS is much cheaper compared to, say, Kinesis. But as you scale up to, say, 1,000 messages per second on average, those services is going to look a lot more expensive compared to Kinesis, because the way the Kinesis charges you is both a combination of both uptime as well as a much lower rate per million requests. So always take into account the throughput that you have in mind, that you're targeting for your system, and the pricing structure that the service you want to use has, and how that applies at your scale. Same applies to API Gateway, REST, and HTTP APIs versus the ALB. ALB's pricing structure is fairly complicated. There's 4 different categories for calculating the ACU you end up going to be using, and at 1 request per second, ALB can be more expensive because of the uptime cost. But then as you scale up to, say, 1,000 requests per second, then that can actually work the other way. but there's also other cases where, if you're handling, because with the way ACLs are calculated for ALB, one of the 4 categories is data processed. So if every single request you are handling, you are receiving a large payload, maybe several megabytes, or you have to respond a large payload from your API, then your ALB is going to end up potentially costing even more than API gateway at a much lower throughput, because API gateway doesn't charges you for data transfer, but at the standard EC2 data transfer cost, whereas ALB charges you for data transfer, but also how you calculate ACL is based on data processed. And so always use the AWS cost calculator to for your particular use case, and to get a rough idea for your throughput, what's the cost for different services. So Werner made the whole thing about the Frugal architect at the last re:Invent, and he had these 7 laws for the Frugal architect. And I think law number 2 and number 3 are particularly, I guess, important in this particular context, because it's basically asking you to look at services whose cost aligns with your business model. So as your business scales, as your business model changes as well, you want to keep changing, evaluating the services that you're using. So if you look at, say, for example, WebSockets is a really good example here, because several services support WebSockets in AWS. You got API Gateway, you got AppSync, you got IoT Core, and that they charge you on similar dimensions in terms of the number of messages that you are broadcasting, you're sending, but also in terms of the connection time. So if the way your business works is that as more users are joining your system, and they have to be connected for a longer time, and so you get your cost. One of the big dimensions that your cost is going to grow by is by the connection time, and not as much by the messages that you're sending. But if your revenue is based on how active the people are on your system, as opposed to just how many of them are connected, are actually on the system, then your revenue is driven by engagement, by essentially number of messages that gets sent, but then your cost is growing on maybe a different dimension faster than the dimension where your business revenue is growing. So this is where, something like Memento, again, they have got a really nice topic, product called the Topics, which also gives you WebSockets, so that you have got this essential topic where the front end can subscribe to it via WebSocket, and the backend can push updates to those topics, similar to IoT Core topics, and then you're going to get updates through WebSockets. And the nice thing about them is that the pricing model is such that they charge you only for data transfer, not for connection time. And so in this case, compared to the other options here, you have here, with the AWS services, you're going to be charged for data transfer cost at the standard EC2 rate. But with Memento, you don't pay for the messages themselves, the count. You don't pay for the connection time. You only pay for the number of messages. So if your business revenue again is going to grow on the dimension of engagement, and as opposed to how many people are connected, then then Memento will be a service whose cost is going to grow in the same dimension as your business revenue. So it will be a much more attractive service to use compared to the other ones that we have from AWS. Another kind of big category of things that you can do to minimize your cost is to simplify your architecture. Again, with the cloud, every architecture decision you make is a buying decision, and every moving part you have in your architecture is additional cost that you have to pay for. And so the general idea is that you want to avoid any unnecessary moving parts in your architecture. So we saw the example from Fathom, where they removed the SQS queue and a second SQS function, in combining everything into one single function. That actually helped them save a lot of costs on the Lambda invocations, but also for the SQS requests as well. And we also talked about how if you got Lambda to Lambda synchronous invocations, you can actually just remove that second function and just do everything in the first function. Then that's also going to help remove unnecessary moving parts, and therefore unnecessary costs from your architecture as well. And some people may think, oh, that's not how we do things, but then how we do things may not work best for us in the way that with the way that serverless technology works, and with the way that we want to build our system going forward. And one example of that is Well, Lambda nowadays has got the function URLs, and even though myself included, I still prefer to use API Gateway as a default when I'm building REST APIs because it's much more flexible. But if cost is where you want to focus on and try to really optimize, then it's actually better and cheaper to have your API running in the Lambda function and exposing it as a function URL with CloudFront. We're giving you the custom domain name as opposed to using API Gateway connected to a Lambda function, because every single user request, you're going to end up hitting API Gateway and paying for that, as well as paying for the Lambda invocation itself. Whereas with function URL, you're not going to be paying for API Gateway. And this is great if you're not using any of the, I guess, nicer features. API Gateway gives you things like being able to integrate with Cognito authorizers and being able to validate your post body based on the request model, or integrate directly with other AWS services and so on. Or if you're actually hitting API Gateway limits, like the 29 seconds timeout limit, or the fact that you need to send back a large payload, which goes beyond the API Gateway's 10 meg response limit. So function URL also allows you to kind of bypass some of those limits. With function URL, your Lambda function can run for 15 minutes. So your API with the function URL can also run for 15 minutes as well. And you can use the response streaming to respond with a large payload by streaming it down to the caller. Downside with using function URL is that you kind of have to write a Lambda lith, and therefore you have to basically live with all the downsides that comes with writing a Lambda lith. Lambda lith is basically a pattern whereby we essentially just run the traditional web application like Express.js application inside a Lambda function, do our own routing and all of that. When you do that, you're not going to have the per endpoint metrics and therefore the alarm, so that everything is going to be aggregated into just one metric and one alarm. You can kind of work around that by creating custom metrics yourself with, say, EMF from Lambda, but that's additional work that you have to do yourself. And also, when you have just one Lambda function, you don't have as fine-grained access control in terms of every endpoint will have a different Lambda function, and you have different IAM permissions that control what that function can do. And also, you don't have the option to have different authentication mechanism methods for different endpoints, because one Lambda function, one function URL endpoint, API endpoint, and so you have just one authentication option to choose from, which is AWS IAM or public. And then the thing to keep in mind is that when you're talking about Lambda lifts, the framework that you actually end up using, Express.js or whatever else, can be quite big. And sometimes those large frameworks are not designed, well, most of the time those large frameworks are not designed for the serverless environment or the Lambda execution environment. So because they're so big, that can also have an impact on the cold start performance for your Lambda function as well. So generally speaking, I think Lambda lifts and so with function URL is best for APIs that are public or that are internal. So it'll be called by another API in your system or a container or Lambda function. So it's only be used by internal processes, and so you can just use the AWS IAM authentication and authorization, which is the function URL support. But if you need to do something that's user-facing, you will have to do the authentication against Cognito and validate the JOT token yourself, which I thought is, it's going to be quite expensive and quite slow. But Brad did some tests, and actually turns out it's not so bad if you just do that using the AWS JOT verify package for Node.js. And turns out it only takes 4 milliseconds to verify the first time. And once that's been done the first time within this one execution environment, subsequent validations only takes less than 1 millisecond. So maybe it's not so bad after all. And then on the flip side, instead of having no API gateway and the Lambda function, just Lambda function, maybe you can go the other way. Instead of having API gateway, having a Lambda and then a Lambda talking to a DynamoDB, maybe instead you remove the Lambda function from the equation and go straight from API gateway to DynamoDB. And one advantage of this is that no Lambda function means there's no cost associated with Lambda, but also there's no cold starts because the cold starts is the Lambda problem, not the API gateway problem. And this is probably less of a pattern that people use for API gateway, but it's a very common pattern for AppSync, because AppSync has got a much nicer integration with other AWS services. And same thing goes to step functions, which has got a nicer integration with other AWS services. So that example I talked about earlier, where I built this new social network for a client in a couple of weeks, about 90% of the resolvers in AppSync was using direct integration going from AppSync straight to DynamoDB, and it's also one of the reasons why we're able to keep the user-facing latency really well under about 20 milliseconds at the 99p99 level. And going even further of this process of simplifying your architecture and removing anything that doesn't add any value, is in some situations, instead of having an API gateway and Lambda function just to allow the front end to talk to get some data from DynamoDB, so you're building a really simple CRUD thing. There's not a lot of business logic in between. You can go straight from the front end to the database, to the AWS services directly. And you can do this safely as well. It's not just a case of we have to trust the front end to call the database with the AWS SDK. How do we get them the AWS credentials, and how do we make sure that people can't read other people's data? So I wrote about this a little while back, and you can do this safely and make sure that you still have that multi-tenancy support, so that the user can't access other people's data by using something in the Cognito identity pool. So imagine you're using Cognito user pool as the user management system. So user will log into Cognito user pool with their username and password and whatnot, and then they can then call Cognito identity pool to exchange that JOT token from Cognito into a set of temporary IAM credentials, which they can then use from the front end to talk to DynamoDB directly without you needing to have an API on the back end just to do some simple CRUD thing from for the front end. So the way to make this secure is that in the IAM role that gets generated by Cognito, and whose credential is then returned to the caller, you have some condition here that says only allow the user to access DynamoDB roles whose hash key matches the Cognito subject. So that way, the Cognito subject is injected into the IAM policy that gets generated for this particular caller, and therefore IAM permission only that they get back only allows them to access their own data. You can apply the same pattern to S3, to pretty much any other AWS services as well. But of course, not every single one of them give you that fine-grained IAM policy control that only allows them to access just their data. So it's not going to work for every single use case. And also, it's probably not for the faint of heart, because if you get it wrong, then this can end up really badly. And also, there's many use cases where you just can't use it because you have maybe regulated requirements that requires to have additional layers of logging and auditing, which of course you're not going to have because it's having the front end talking to the database directly. And also there's a lot of other things in between that you may have to, that you may need to do in terms of rate limiting, in terms of having to put a sensitive business logic, like a lot of the banks, for example, the business logic is their secret source. They don't want to expose that to anybody else. So, to do this, you have to put a lot of those logic in the front end. But also on the front end side of things, you have to essentially bundle the AWS SDK in order to talk to the AWS services, which of course makes the front end bundle much bigger and potentially have an impact on the front end performance as well. So a lot of much more reason to not do this than the reasons to do this. But if you really want to optimize your cost, because you're building maybe as a personal project and side project, and you want to make sure that you keep your cost down to as minimum as possible, and you're just doing very simple CRUD API, then this is something to think about as a potential option. And so we talk about quite a few number of different things today. We talk about everyone needs billing alarms and some things you can do to keep the monitoring costs under control. And then also why you need to avoid lambda calls because it's just a waste of compute power and cost. And caching is a really good way to save on cost because you can it also helps you make systems that are more performant and scalable. Root 53. If you've got domains that are stable, it doesn't change very often, then use a longer TTL so that you reduce the amount of queries that people have to make, and therefore your cost as well. Make sure you choose the right service. Use the AWS calculator to work out what's the estimated cost for your use case for a given service. And simplify your architecture because everything that you're adding, every step in your architecture, every moving part in your architecture is a cost. And so simplifying your architecture can oftentimes also means significant saving in cost as well. In terms of simplifying architecture, Lambda function URL is a good way to simplify REST APIs. And for things that doesn't require a lot of custom logic, you can also use functionless approach to have AWS services like API gateway and AppSync and step functions bypass Lambda functions and go straight to the databases and queues and whatnot, so that you save on the cost of Lambda functions. And for the really extreme cases, just don't have API at all and have the front end talk to your backend databases directly, and you can do it safely. All right, so that's everything that I've got to prepare for. Yeah, so I think you guys have put some questions in the chat. So let me just quickly pick those up and see where's the chat window. Oh, there you go. See if you've got any questions. Lumigo. Okay, yeah, the monitoring app that I showed was Lumigo. Just go to lumigo.io. Caching on reverse proxy and proxy is then an option too. Yeah, it depends. I guess I mean, most of the time, I just use the CloudFront, and that seems, that's good enough for, I would say, about 95% of my use cases. I don't really tend to run reverse proxies myself, but if you do, then that's also a place that you can do caching as well. It'll be similar to the use cases where you may want to use the API gateway caching instead. But honestly, no, API gateway's caching is more flexible than CloudFront, but pretty much in every single use case I've had, CloudFront has been good enough. And most of the cases where I need additional caching, that will be in the application layer, where maybe I'm doing some computationally expensive thing. I don't want to do that over and over, and so I can put the cache response in Memento and only pay for the actual usage in terms of data transfer, as opposed to paying for uptime for say Elasticache. And curious on TTL in caches set. So TTL on the caches, it really depends on use case. So for something like the AppSync API that I talked about, the social network, AppSync gives you the ability to configure caching for different settings for individual resolvers. So for things that are more kind of, I guess, static data, we have really long cache at TTL. But for things that are like, oh yeah, someone just posted a new tweet, their profile images and things like that doesn't change very often. So we have kind of medium length the TTL on those. But for things like for things like maybe, let's say, what's example, number of likes and things like that, on the some of the stats on the tweet, we cache that for a much shorter period, for maybe a few seconds or for a minute, which at scale, when lots of people are loading the same tweet at the same time, that can still be really useful in terms of just mitigating the number of calls you have to make to the backend services to get the most up-to-date number of likes on a particular tweet, for example. So no, ideally you will have you use a different TTL depending on the particular piece of item that you are caching. Satish asks, can this presentation be shared? Oh yeah, sure. I would share that with Daniel, and then Daniel can distribute to everybody else. Nikhil says, great point about messaging service cost within AWS in terms of small volume at the start versus large volume a couple of years into the life of a startup. Yeah, absolutely. I've been stung by that quite a few times, and I've seen a lot of people, a few blog posts that came out a couple of years ago talking about how serverless is expensive. And if you look at it, most of that cost is actually just attributed to API gateway, because this person build a system, they migrated to serverless, and they were doing a couple thousand requests per second. And so API gateway is much more expensive at that kind of level of throughput compared to ALB. So a lot of times, making one change in terms of the service you're using can make a big difference as you scale. And we also have the example from, say, Prime Video. So they started with step functions because it allows them to go to market quickly on a system that they don't know if anybody's going to use, but then a few years later, turned out to be a really popular service, and they were, accumulating a lot more cost, and so they migrated that workflow into containers and keeping a lot of the code that they had, in Lambda functions, and so they were able to basically re-architect without having to rewrite large parts of their system. So and then they'll be able to cut the cost by 90%. So again, some services make sense when you want to go fast, when you need to often change things quickly. But then once you get to certain scale, when you don't have to have a new requirement every single day, you don't need the agility as much, but you need to optimize for cost. Then they're looking for services that charges you based on uptime is often tend to be order of magnitude cheaper compared to services that charge you based on usage only. Satish says that during scaling, Lambda sometimes take more time to boot up if they have dependent database connections. Is that something necessitates to have fine-grained Lambda functions? Please advise. So are you talking about connections to things like RDS or to a database proxy? So if that's the case, it might help to have a fewer number of Lambda functions, but it really depends. So if at peak you need to have, say, 100 different instances of the same function versus maybe say 10 instances of each for 10 different functions, then in total you still have the same number of concurrent execution environments that need to connect to your database. So it's it depends on your actual pattern, but yeah, sometimes it can actually end up working better if you have a fewer number of functions. So one Lambda lift, for example, instead of lots of different functions, one per endpoint, so that depending on how your traffic pattern is distributed across different endpoints, you can probably consolidate the number of execution environments you need to have to handle the same number of requests per second. So that's also one reason I see a lot of people actually initially move to Lambda lift as well, is because they're running into some connection limits downstream. But you can, I think with a database proxy, you can probably get up to quite a high number of connections. So it hopefully shouldn't be a problem. If you are connecting to RDS directly, then yeah, that's a much more common problem I've seen people have when you have a direct connection to RDS than when you go through the database proxy. Sure.
So Yan, sorry, I have a question. I didn't type it down. It's easier to articulate it. So looking for your suggestions. So first part of the question is about WAF.
Yep.
This is one cost which I'm seeing ballooning out of control when you have S3, CloudFront, and WAF. And the other one is about using very expensive EC2 instances, which we need, but waking up in the middle of the night, did I turn it off? Did I turn it off? Like, you don't want to lose your sleep if it's running or not. So do you have any suggestions on these two?
Yeah, so WAF charges you based on the number of requests that you evaluate. I think it's about 60 cents per million, so it's cheaper than API gateway for the same so I guess per million. But it also charges you based on number of rules that you have as well. So maybe it's do you know if most of the cost is coming from the volume as opposed to the number of rules that you have?
It's basically, I'm trying to understand if it's basically for a static site with like 100,000 plus pages. And people are scraping, or if they're trying to hack it or something, just need to monitor it.
Right.
That itself is costing, yeah.
Okay, interesting. Yeah, so that's I mean, if it's just a request, the number of requests that you're seeing, that's causing a problem, then there's not a lot you can do apart from just using a different service. There's a few other services. I know I think Cloudflare may be more expensive than CloudFront, but there's also Bunny as well. A few of them have got the equivalent of a WAF, and they may be included in the price. I think for Bunny they only charge you for data transfer, and the data transfer cost is cheaper than CloudFront, and so that might be a case that you just need to have a look at some other vendor instead of a CloudFront, or maybe reduce the number of rules that you're using. But I don't know if I think the volume charge is not dependent on the number of rules you have, though.
Or just turn it off. I mean, just turn it off.
Turn it off is an option, but then the question is, what does that open you up to in terms of security risk and an attack vector?
Okay. Sorry, the other part was about the EC2 instances. Is there any way to know happily that the instance, is there a pattern you can establish to make sure the machines never stay on beyond you need them?
Yeah, so what you can probably do, just have a Lambda function that that gets triggered, and so that you have a cron job that triggers a Lambda function to turn it off at the a certain time, and so if that instance is still up at that time, then it just forcibly turns it off. That's probably easy thing to do. Other than that, there may be, I think there's also event bridge rules they can use as well. So for example, you may be able to say, okay, use the event bridge rule to say if you see EC2 instance that EC2 instance's state changes from stop to started, and you check the current time. If the current time is past your curfew, you can then use Lambda to listen to that rule. That event is going to get published to the default event bus, and you can use the Lambda function to automatically stop that instance, so that after that certain period, well, like 10 o'clock at night, you can then just forcibly turn it off. Someone says you can also use the instance scheduler to automate the process. I haven't used it before, so I'm not sure. But yeah, I imagine there's some scheduling thing you can use. But if you worry about someone turning on manually after the scheduling, that the scheduler has turned it off, then you can use the event bridge rule to listen for state changes for that instance, and then automate some process to turn it off again.
Perfect. Thank you.
Victor says, thank you for the great presentation. Yeah, any comments on Lambda inside the VPC and costs associated with it? Net, any serverless alternative to VPC flow log? Yeah, so Net, it's one of the top items I often see for people that are using Lambda and VPC. Unfortunately, there's not a lot of way to get around it. Most of it you end up using VPC endpoint instead of using Net, which is much cheaper compared to Net. But usually it's you charge at a lower rate per VPC endpoint, but you still end up paying for something. It's just paying at a slightly cheaper rate compared to Net. So your main option would be to use the VPC endpoint. Or if you can avoid it, then don't put the Lambda into VPCs if there's no particular reason for it. But I know in a lot of enterprises, it's a regulatory requirement that everything is accessible only from within VPC. So all your databases, and including DynamoDB and OpenSearch and RDS, is only accessible from VPC. So you have to put your function into VPC as well. In which case, sometimes the Net is just unavoidable, unfortunately. As to serverless alternative to VPC flow log, I don't think there is any, because if you're using VPC, then the only way to get those flow log is from VPC, from the AWS VPC directly, unless you use some third-party services. I know some clients use F5 Silverline, but that's even more expensive. It's really expensive, but it's got better integration with some other third-party solutions. But yeah, I don't know any server alternatives to VPC flow log. Satish says, thinking how is Kafka different from SQS? Piece of advice. So Kafka is probably closer to Kinesis in terms of the way you process. So it's a stream. So it's a stream. So you can have multiple subscribers. For one, is multiple subscribers can subscribe to the same stream, and they're gonna get the events from the stream in sequence. Whereas SQS is when you go one SQS queue, different people can poll the queue, but then the same message will not go to every single subscriber. Only one person gets one message at a time. And so it's more of a task pattern, so that if you want something to be done by someone, you put it onto a queue and let them do it at their own pace. Whereas if you got events that you just want to share with everybody else, then that's more what you would do with Kafka or Kinesis, and you want the consumer to process those events in a sequence, as in a stream. That's what you would use Kafka for, instead of you wouldn't use SQS for that. But yeah, Kafka is I guess Kinesis is the kind of the similar thing on AWS to Kafka. Very different the scaling model, though. I think different behaviors in terms of scaling, how it scales horizontally.
Yeah, and like I'm just thinking, like what is the reliability point of view? For example, like I have a message that has to be delivered, and in the case sometimes I have seen that Kafka, the messages are getting dropped, or there could be some loss of message. So I'm,
that shouldn't be the case. I've not seen that. That if Kafka has accepted a message, it should be delivered. And the same will go to SQS or Kinesis as well. So that if a message has been accepted, they should be delivered. I'll suggest maybe have a look at maybe the problem is in any filter that you have, because I think Kafka allows you to have filters in the subscription so that you can filter out some data. Maybe that's where data is missing. But as far as I know, once the message is accepted by Kafka, it shouldn't disappear. It should be delivered to the target.
awesome. Thank you.
There may be things like maybe like deliver the problem with the Lambda function that you're delivering to. There may be a problem with the function so that you didn't see that in your function logs. That's where you can with things like Kinesis, SQS, SNS, there's always some mechanism you can use to set up a delta queue for the delivery, so that I don't know if they do that for Kinesis. You can connect your custom Kafka to Lambda, but then you can potentially, because it's using event source mapping, you should be able to set a delta queue there as well, so that if there's a problem delivering to your Lambda function because maybe you are getting throttled or there's some problem with your function, maybe there's some IAM permission problems, then you don't lose those messages. Perhaps that's what's happening there, that there's problem with the delivery. But then with Kafka, maybe you're not using one of the sort of built-in mechanisms that you get from Lambda. So you don't have like a delta queue for delivery problems. Perhaps that's the issue there. So what are you using to process the messages from Kafka?
So we have like stream processing. So it connects to the topics and processes the streams, and yeah.
And is that using like EC2 or containers, or is that Lambda function with event source
This
mapping?
is like not in AWS. We're using in Java Spring Boot kind of a Kafka there.
Okay. Yes. Okay. Then I don't know. I've not done that myself. But maybe I guess to investigate is whether or not I guess if you're pulling the messages, there should be some logs, so it shouldn't just go disappear between it being accepted by Kafka to you trying to pull it and it's not there. Shouldn't disappear. But I at least I've don't use Kafka enough to know for sure. But my expectation is that the data should be, once it's accepted by Kafka, it should be delivered.
Awesome. Thank you.
No worries.
3 more minutes. Any other? This is awesome. Thank you so much.
No worries.
Any other questions? My question is, when you're in Toronto specifically, I will try to organize something informal, just for the people to meet and greet you and maybe have a drink.
John says, Memento looks cool. Looking forward to trying out topics. Yeah, it's a very nice service. I really love the fact that for topics that they don't charge for connection time, because I've had a few use cases where there's a lot of users, but the number of activities not all that big, and with AppSync we have to be really careful in terms of how long we stay connected for, so that we don't end up paying for a huge amount for connection time. But yeah, it's because a lot of time we use it for things like, oh yeah, we're connecting to the website, but then we're gonna push updates, but then the things there's no update, but you're still gonna get connected for like 5, 10, whatever minutes at a time. So yeah, like not paying for connection time is great. Yeah, I really like the service. It's very nice and easy to use as well.
Yeah, it looks great. I put something together years ago with push messaging, and I used the IoT core, which works, but there's a lot of pieces there to put together and get all the right things just perfect before it was. I need both application side and server side. So no, that looks great. It's just a service bundled up that does the whole thing.
Yeah,
and we've used them for caching, and they've been incredibly helpful for us. So. I said before +1 on Memento, and I would say it again to anybody who asks.
Yeah, it's great. And also with IoT core, you have to wrap the whole thing in MQTT. So you have to wrap all your messaging in the application layers in MQTT, and yeah, we have this is just like a vanilla WebSocket connection. So you can do any application level protocol you want to implement yourself. Rafaela says, no, not a question, but thank you for the great presentation. I work in cloud financial management, but none of my clients that double with serverless infrastructure, so I'm not familiar with the topic. This was very informative. Oh, thank you. If you've got any questions, feel free to ping me afterwards as well. You can find me on social media as the Burning Monk on Twitter, and you can find me on LinkedIn as well. So yeah, you can always reach out to me if you got any follow-up questions.
Perfect. So you're ready for the mining raffle? And again, when are you in Toronto?
Oh yeah, I'm in Toronto from the 3rd of May to the 9th.
Okay, so I will reach out to that place, My Planet, 3rd to 9th. Which day is best for you and what time in the evening? Like, if folks are working from home, it's going to be hard to get.
Yeah, yeah, I think let me see. I think I'm doing. Let me see what day I'm working at the client side. I'm busy on 8th, but other than that, I think I should be okay. Any of the other days.
Perfect. We'll see. I don't promise, but it would be good social event, no lectures, just people to hang with you and maybe have pizza and a drink. If My Planet is still in business and they still allow nonprofits to get together there, so that I will try that. So you can see this mining publication screen now, can you?
Yep.
So this is a mining raffle video. Please, so we have a news this month. They gave us a 45% off whole year. So if you are into buying mining books, use this weird URL or this barcode and enter Toronto 24 code anytime. So if you didn't win, you'll be able to do that later. And then I was able to collect all names for the, not too many of you entered their names. Anybody else wants their name in, or I can spin? I'll spin. Satish, are you with us?
Yeah, I'm there.
Perfect. Paste your email into the chat, and then congratulations. And then I'll connect you with the nice folks for mining to choose any of the product they have, but single product, no bundles. So
Awesome.
that would be from me. Let's stop sharing. How do I do that? Still new to Zoom. Somebody raised hand. Okay, go ahead. Sherry.
Oh, maybe she was just trying to get her name in the raffle. It's too late.
Next month. Sorry.
Sorry, was there a question, Jerry? Not sure. Okay.
Any other questions?
Oh yeah, she was. I see it in the chat. I see it in the chat. Very good.
Thank you, Yan. So I hope to see you in person next month. We'll try to organize something. And it's lovely to see you again and learn from you. Just true guru.
All right. Thank you so much for having me today.
That was awesome. Amazing knowledge there.
Thanks, everyone. Enjoy the rest of the day. Okay.
Yeah.
Bye-bye.
Thanks.
Thank you.
Yeah.
Bye-bye, everyone.
Thanks, guys. Bye.